Today we're going to break down one of the most important searching techniques in programming. Linear search, the simple but slower method. Binary search, the faster and more efficient method. So, let's get started. Before we dive into the two types of searching, let's understand the problem. Imagine you have a list of numbers. Now, I ask you to find 42 in this list. How would you do it? There are two main ways to search for an element in an array. Linear search, checking one by one. Binary search, using a divide and conquer approach. Now let's break them down. Linear search. Linear search is the simplest searching technique. It starts from the first element and goes through the list one by one until it finds the required number. How linear search works. Suppose we have the list 10, 25, 37, 42, 50, 66, 78. Now, we want to find 42 using linear search. Start from the first element. Is 10 equal to 42? Number move ahead. Check the second element. Is 25 equal to 42? Number move ahead. Check the third element. Is 37 equal to 42? Number move ahead. Check the fourth element. Is 42 equal to 42? Yes, found it at index 3. Conclusion: linear search is simple but slow for large datasets. Binary search. Binary search is a much faster searching technique, but it only works if the array is sorted. It follows a divide and conquer approach to eliminate half of the elements in each step. How binary search works. Suppose we have the same sorted list: 10, 25, 37, 42, 50, 66, 78. Now, we want to find 42 using binary search. Find the middle element. Middle index equals open parenthesis, 0 plus 6 close parenthesis, divided by 2 equals 3.0. Middle element equals 42. Is 42 the number we are looking for? Yes, found it. Conclusion: binary search is super fast but requires a sorted array. And that's how linear search and binary search work. Linear search, simple but slow. Binary search, super fast but requires sorting. Hello everyone, welcome to The Bug. Today we're going to explore a C program that demonstrates two important search algorithms: linear search and binary search. By the end of this video, you'll understand how these algorithms work, how to implement them in C, and why they're useful. Let's start with the beginning of the program. Define max size 100. This line defines a constant called max size with a value of 100. A constant is a fixed value that doesn't change during the program's execution. Here, it represents the maximum number of elements our array can hold. Include stdio.h. This includes the standard input-output library .h. It allows us to use functions like printf to display messages and scanf to take user input. Think of it as adding tools to our toolbox. Next, we define the linear search function. Let's break this down. Function signature int linear search, int r, int n, int key. This function takes three arguments. AR bracket bracket. This is the array where we'll search for the element. N. This is the number of elements in the array. Key. This is the element we're searching for. The function returns an integer, the index of the key if found, or -1 if not found. How it works. We use a for loop to go through each element of the array one by one. Inside the loop, we check if the current element, AR of I, matches the key. If it matches, we return the index I. If the loop finishes without finding the key, we return -1 to indicate the key is not in the array. This is called linear search because we check each element in a straight line, from start to finish. Now let's look at the binary search function. Let's break this down step by step. Function signature int binary, search int r, int left, int right, int key. This function takes four arguments. R. The array to search in must be sorted. Left. The starting index of the search range. Right. The ending index of the search range. Key. The element we're searching for. The function returns the index of the key if found, or -1 if not found. How it works. We use a while loop to repeatedly divide the search range in half. Inside the loop, we calculate the middle index, mid equals left plus right divided by 2. If the middle element, AR at mid, equals the key, we return mid. If the middle element is less than the key, we move the left index to mid +1 to search the right half. If the middle element is greater than the key, we move the right index to mid -1 to search the left half. If the loop ends without finding the key, we return -1. This is called binary search because it repeatedly divides the search range into two halves. It's much faster than linear search but requires the array to be sorted. Now let's move to the main function, where the program execution begins. Let's break this down. Variable declarations n stores the number of elements in the array. Key stores the element to search for. Choice stores the user's choice of search method, 1 for linear search, 2 for binary search. Result stores the result of the search, index of the key or -1. Our max size declares an array of size max size 100. User input. The program asks the user to enter the number of elements, n. If n exceeds max size, it displays an error and exits. Next, the program asks the user to enter the elements of the array. A for loop is used to read n elements into the array. Then, the program asks the user to enter the element they want to search for. Finally, the program asks the user to choose a search method. If the user chooses 1, the program calls linear search. If the user chooses 2, the program calls binary search. If the user enters an invalid choice, the program displays an error and exits. After performing the search, the program displays the result. If result is not -1, it means the element was found, and the program prints the index. If result is -1, it means the element was not found. Let's go through an example to see how the program works in different scenarios. Suppose we have the following array. Scenario 1, linear search, element found. User enters key equals 30. The program checks each element R0 equals 10, not a match. R1 equals 20, not a match. R30, match found. The program returns 2 and prints element found at index 2. Scenario 2, linear search, element not found. User enters key equals 25. The program checks each element but doesn't find a match. The program returns -1 and prints element not found. Scenario 3, binary search, element found. User enters key equals 40 and chooses binary search. The array is already sorted. The program performs binary search. First, it checks the middle element R, 2 equals 30. Since 30 is less than 40, it searches the right half. AR at index 3 equals 40. Match found. The program returns 3 and prints element found at index 3. Scenario 4, binary search, element not found. User enters key equals 35 and chooses binary search. The program performs binary search. First, it checks the middle element R, 2 equals 30. Since 30 is less than 35, it searches the right half. R at index 3 equals 40. Since 40 is greater than 35, it searches the left half but finds no elements left. The program returns -1 and prints element not found. This example shows how the program handles all possible variations of the result. And that's it. Today, we learned how to implement linear search and binary search in C. We also walked through an example to see how the program behaves in different scenarios. Remember, linear search is simple and works on any array, but it's slow for large datasets. Binary search is much faster, but requires the array to be sorted. If you understood the program, don't forget to like, share this video to your friends, and subscribe The Bug for more programming tutorials. Happy coding, and I'll see you in the next video.